Hello again, Math 10Cs. In today's lesson, we are going to continue to use all that knowledge we gained from the previous lesson in terms of how to use the graphing calculator to plot a relation on a graph, adjust window settings, calculate the X and Y intercepts to solve some more problems today. In fact, we're not going to use any new functions from the graphing calculator. We're just going to continue to reinforce the material that was learned in the previous lesson. We're going to start off by revisiting a problem that we dealt with back in lesson number 3. Specifically, it was example number 3, and that dealt with the problem where you had like a car that's depreciating in value. So just to read that problem again, Lisa purchases a new car for $20,000. The value of the car can be represented by the formula V is equal to 20,000 minus 1250T, where V is the value of the car in dollars and T is the age of the car in years. For part A, we want to graph that relation, V equals 20,000 minus 1250T using a graphing calculator. Then we want to adjust the window settings so that they are the best window settings for the context of the problem. And then in this grid that we see on the right-hand side, we want to sketch what the graph looks like. Before I get into actually graphing it, I'm just going to label the grid that we see on the right-hand side. So if I look at my equation, T, that's my independent variable. Your time is your independent variable, or it's going to be represent a bunch of input values. So we're going to label that on the x-axis. Okay, so T. And then V represents your output or your responding variable, your dependent variable. We're going to put that on the vertical axis. Now, to put this in your graphing calculator, I'm going to write it in the form that I need to plug it in to the y equals function. So we want to write down, instead of V, we're going to write down y1 is equal to 20,000. And then subtract 1250 times, instead of T, we're going to write down X. The first thing we're going to do is we're going to go over our graphing calculator. Now, I have a bunch of stuff on here from the previous lessons. I think I'm just going to do just a memory reset just to start off with all the default settings. So I'll just hit second and then the plus sign for memory. Go to number 7 for reset, and then just clear all my RAM. You don't necessarily have to do this, but I just don't want anything on my screen. Okay. Now, in the graphing calculator, we're going to plug in y1 equals 20,000 minus 1250 times x. So I'm going to click on the top left button, y equals. And in the place of y1, I'm going to type in that equation, which is 20,000. And then subtract 1250. And the X button is directly beneath the mode button, so just hit that. Now, if I graph this, I'm not going to get a very good graph. Let's see what we get here. I don't see anything, okay? So this clearly is not good enough window settings to deal with this. What we can do is we can try using the zoom fit feature just to see if the calculator will give me like a good view of what the graph is. So I click on zoom, and then zoom fit is going to be 0. So you scroll down to the very bottom. You don't need to scroll down here. You can actually just hit 0. Okay, and then you get a graph that looks like this. Now, this is also not a good graph for a couple of reasons. So what you want is a good graph should clearly show both the y and the x intercepts. So if I look at the graph here, I can definitely see the y-intercept, no problem. I can kind of see the x-intercept, but I should be able to see both sides of the axis that it hits. And the other problem too is that in this problem, the x-axis represents time. Time cannot be negative values. So there's really no reason to have like all of this space on the left-hand side if the time's just going to be 0. Okay, let's do some manual adjustments here. But I think what I'm going to do first is I'm just going to hit the trace button and just kind of like help identify what the x and y intercept is, just to make me adjust the window settings better. So I'll hit trace. Now, mine goes straight to the y-intercept. So it says when x is 0, y is 20,000. Okay, so the reason I'm going to this is going to help me identify like what is my y max value going to be. So I'll make my y max value a little bit bigger than 20,000, but I don't want y max to be anything less than this. Otherwise, I won't see the y-intercept. Now, as for the x-intercept, we just have to just hit the right button until we can get all the way down here. So this is gonna help me identify what the x max should be. Okay, and it's looking like it's going to hit at about 10. Okay, so now what I'll do is I'm going to manually adjust my window settings. So I'm going to go to Window. Now, x min means what's your minimum x value. Now, the variable we're talking about is it's not x, it's time. So time can't be negative. So let's make our minimum x value 0. The x maximum is 10. So we identified that's where it hits that's where it's going to hit the x, that's where the x-intercept is going to be. The y-min is going to be, well, your car really can't have like, I mean, the lowest value the car could get would be $0. Like you can't really have like a negative value for the car. So we'll hit 0 there. And then that y-intercept, which I'll use as my y maximum, I'll put down as 20,000. Okay, let's regraph it and see what this looks like. Okay, it's still not that great. So I can't actually see the x-intercept here. So I think I was wrong when I was identifying what the x-intercept is. Oh, it's because the scale probably went up by a different number. Okay, so let's change this. So going up to an x max of 10 just is not good enough. So I'm going to go back to the window setting. And let's change the x max to like 20. Go ahead and graph that. Okay, that looks pretty good. Now I'm going to make one small adjustment because we're going to have to use some calculator features where we actually need to make a left bound to the left of the x-intercept and to the right of the x-intercept. So even though you can't have negative time or the value of the car really can't be negative, I'm just going to change the x minimum so there's a little bit of a negative number in there just so I can see both sides of the x and y axis. So I'm going to go here and we'll change the x minimum to -2. And then we'll go over here and we'll change the y minimum to maybe like -500 or something. I'm just doing this so I can see both sides of each axis. Okay, let's change that. Okay, I'm going to make the y-intercept, the y maximum a little bit bigger just so I can see that line cross. So I'll go back and I'll change the y maximum maybe to, let's do like 25,000. Okay, not bad. I can clearly see both sides of the y-axis. X-axis, maybe we could add a bit more of a negative number here. So let's make it, so I'll go back to window and I'll hit x minimum as, let's do like -5. See what that looks like. Oh, that's not really the issue. The issue is, sorry, let's go back here and change that to -1. The issue is I can't see far enough below. So I'm going to make the y minimum a little bit bigger. Okay, but let's change this x minimum back to -1. That's fine. The y minimum, let's make it -1,000. Let's see what this looks like. Okay, that's not bad. Okay, so what I can see here is the graph focuses on quadrant 1, which makes a lot of physical sense because that's where your time is positive and the value of the car is positive. I can see both sides of the, like if I want to have my y-intercept, I can see both sides of that axis. And same with the x-intercept, I can see both sides of that axis. There's no like cut and dry way to do this perfectly. You kind of just have to play around with the window settings. And again, you can see that there, like I just kept like tweaking it little by little until I got like the graph that I really wanted. Okay, so let's identify what those window settings are. So I'm going to write them down here. Okay, so we had X min was -1, we had X max of 20, and we had X scale of 1. So let's go back to my Smart Notebook file. Let's just write down what those window settings were. So for my X values, okay, my X minimum was -1. I think I made my X maximum 20. And then my X scale was 1. Okay, so it says write the window setting below. That's what I'm doing here. Yeah, -1, 20, and 1. And then the Y scale, the way in which I plotted the Y window settings was Y minimum is -1,000, Y maximum 25,000, and the Y scale of 1. So if I go back here, I can write down, it was -1,000, I think. Let's double check that. Yeah, -1,000, 25,000, and then the Y scale was, whoops, my scale was 1. Okay. And then let's sketch the graph based on what we see in our calculator screen. So let's go back here, and it looks something like this. So I'll just grab a line and I'll just sketch it. So let's go grab a line. Let's make it blue in color. And okay, so it looks like it starts at about here and does something like this. And we can just add arrows at the end of the line just to show that it's continuous. Okay, arrow here, arrow there. Okay, that roughly looks like what I've got. Maybe it's stretched a bit more horizontally, but that's okay. Okay, I'm just sketching it. Okay, B says calculate the T-intercept of the graph using the graphing calculator and label it on the sketch and describe what this value represents in the context of the question. Okay, so the T-intercept is going to be the X-intercept. The way to get the X-intercept is you want to use that 0 function. So the way to access that is you would hit second. And then trace. Which will actually access the calculate. And then you pick option number 2, which is going to be 0. X-intercept is when Y is 0. So let's go ahead and do this. We'll hit second, trace, number 2. Okay, now you have to put the cursor on the left side of the X-intercept. So I'll just make it go down here. Hit enter. Go to the right side of the X-intercept for the right bound. Hit enter again. And it tells me that when Y is 0, X is 16. So let's go back and label that now. So we have X is 16, Y is 0. But let's use the actual correct variables. It's not X, it's T. So you'd have T would be 16. And then you'd have V would be equal to 0. Okay, so, and let's write down the units here. So T would be 16, and time is in years. All right, let's box that. Now it says describe what this value represents in the context of the question. Well, after 16 years, the car has no value. So just the time it takes for the car to have no value. C, calculate the V intercept of the graph using the graphing calculator and label it on the sketch. Okay, so the V intercept is going to be the Y intercept. The way to determine a Y intercept is we're going to hit second. So you start off by doing the same thing, second, and then hit the trace button, which will access calculate. And this time you want to pick option number 1, which is going to be value. And then it'll prompt you to enter a value of x. So the y-intercept is going to be when x is equal to 0. Let's go ahead and do this. So we'd hit second, trace, pick option number 1, and then it prompts you to enter a value of x. So the y-intercept is when x is 0, so you hit 0, and then it tells you when x is 0, y is 20,000. So go back here and write that down. When x is 0, y is 20,000. But let's write it down in terms of the actual correct variables. So when t is equal to 0, v would be equal to, and 20,000. And if we write down the units for v, it's $20,000. Okay, that's the y-intercept. And then it says, what does this mean in the context of the question? Well, when the time is 0, that's actually the original price of the vehicle. So this is the original price. Original price before any depreciation has begun to occur. D says use the trace feature to figure out of the graphing calculator to determine what the value of the car will be worth in 5 years. Okay, so this is actually pretty easy. All you need to do is you're just going to hit the trace button. And then if you immediately type in a number, so I'm going to type in 5. What this is going to do is if you hit trace and you enter 5, it's going to plug in x equals 5, and it's going to tell you what the value of y is. So if I go ahead and do this, so hit trace, and then hit 5, and then it says, okay, so now we're inputting a value of x is equal to 5. So that's going to be the value of the car after 5 years. Hit enter, and it tells me it's 13,750. And again, we can write this in terms of the correct variables. It's not y, it's v. So v would be 13,750. And that's after 5 years. So that's when t is equal to 5. E says use the intersect feature of a graphing calculator to determine when the car will be half of the purchase price. Illustrate this on your sketch. Sure. Okay, so half the purchase price would be 20,000 divided by 2. So half the purchase price is going to be 10,000. So what I'm going to do is we want to determine what is the value of x when y is 10,000. Now the way to do that is you actually need to enter a second equation into the y equals. So what I'm going to do is into the place of y equals, beside y2, I'm just going to enter in 10,000. That's going to draw a horizontal line that's going to start at 10,000. It's going to hit my graph. Go back to my calculator, hit y equals, go down here, hit 10,000. Go ahead and graph this. And now I can see this horizontal line that hits my graph. So this horizontal line is when the value of the car is 10,000, and we want to figure out how long it takes to actually get that half the value. Okay, now it does want to sketch us on the graph, so let's just quickly go back to my graph and do this. So we'll just do a red line. Okay, red line, half the value would be about right here. Okay, so the line just looks like this. And then we can just put the arrows on the end of it as well. Okay, now we're going to use the intersect feature to figure out what's the value of t when what is the time when you have half the value. So the intersect feature, so I'll write these keystrokes down. So you'd hit second, and then calculate, or second trace, sorry. Which is calculate. And this time I want to use the intersect feature. So I think that's number 5. Okay, so let's go back and do that. So we hit second, we hit trace, we pick option number 5. Okay, it says first curve. So we're on the blue line. So get that cursor to come close to the intersection point and then hit enter. And the second curve, so we're along the horizontal line. And same thing, just make the cursor come close to the intersection point and then hit enter. Then it says, do you want me to guess the intersection point? And it says, when x is equal to 8, y is equal to 10,000. So we can go back and we can label that. I'm kind of running out of space here, though. No problem. I'll just do it down here. Okay, x is equal to 8. Y is 10,000. So how long does it take for the car to have half the purchase price? 8 years. Okay, it's not x, it's t. 8 years. B, or not B, F, write an appropriate domain and range for this function that describes the value of the car over time. Okay, so let's do the domain first. Okay, now you have to make physical sense of what's going on here. So the domain, it doesn't make any sense to write down any negative time values. So your domain, your t values would start at time equals 0, and it would end at the final, it would end after 16 years. So it would end when the car no longer has any value. I don't want the time to go beyond that. So my domain is going to start at t equals 0, and it's going to end at this X-intercept when you no longer have any value of the car. So the way I would write this is we'd write down t is greater than or equal to 0, okay, because time must be a positive number, and t is less than or equal to the time it takes for the car to have no value. So that'd be 16. And then if you're in this little area here from 0 to 16, time can be any real number. The range. So let's make physical sense of this. So the lowest value that the range is going to be the value of the car. The lowest value you can have is 0. You can't have a negative value for the car. And the maximum value for the car would be the value that you start off with, which would be 20,000. Therefore, when I'm writing down the range, I would say, okay, so the value of the car must be greater than or equal to 0, but it must be less than or equal to what its original price was. And that's the price when you started things off. So that's 20,000. And then the value can be any real number as long as you're in that range. Okay, let's go to the next example. There's only 2 of these to go through. Okay, the height of a human cannonball can be described by the formula h is equal to 12 plus 6t minus t squared. So right away, this is going to be a nonlinear relation. H is the height in meters above the ground. T is the time in seconds. Kano is projected out of a cannon from the top of a building and lands on a soft mat. The mat is placed in a hole in the ground, so the top of the mat is level with the ground. A, display the graph of h equals 12 plus 6t minus t squared on a graphing calculator. Okay, so let's actually label the graph first. So your independent variable will once again be time, and your dependent variable would be the height. So we'll put time on the x-axis and we'll put height on the vertical axis. if I'm going to plug this in my calculator, instead of h, we're going to plug into y1. So I'm going to have y1 is equal to 12 plus 6. Instead of t, we're going to write down x minus x squared. Okay, so let's go back to the calculator, and I'm just going to clear everything again. Okay, so I'm going to go to second, memory, 7, 1, 2. Okay, just gets rid of everything. Okay, let's plot that equation into the calculator. So for y1, so that equation is going to be 12 plus 6x. Again, x is under the mode button. And then minus x squared. Okay, let's see what happens if I graph it right now. Do I see much of anything? I see something. Yeah, so this is going to be like one of those curvy shapes. So it's basically curving up to a maximum, then it's going to come back down. But I can't see everything. What I really want to see is I want to see the spot where like you have like the top of the curve. Okay, the top of the curve would be somewhere off of the off the very top here. So this is, I think the x scale is okay, but it's the y scale that's not high enough. Let's see what happens if we do zoom fit. Okay, if zoom fit any better, so hit zoom and then 0. What does this look like? Yeah, I mean, okay, so I mean, this is an okay starting point, but the problem is it's focusing on too much of the area that doesn't make any physical sense, because the entire left-hand side of the graph is negative time, which we don't want, and the bottom part of the graph represents a negative height, which we also cannot have. So let's start to adjust the window settings just to get rid of that. I don't really want to have negative time, and I don't want to have negative height. So we'll go to window. Okay, so x is the time. So we don't want negative time, so let's write down 0 for your minimum time. And your minimum height above the ground should just be 0. Okay, let's see what this looks like. Is this any better? Yeah, that's a lot better. Okay, so it's focusing on the area of the graph where the problem actually physically makes sense. I'll do a couple things though. So again, we want to see both sides of the x and the y axis, and I'd also like to see a little bit higher compared to the very top of this curve here. So we're gonna make the x min just a little bit more. We're gonna make the y min a little bit more. We'll make the y max a little bit higher. So I'll go back to the window setting. We'll change x min to like -1. We'll change y minimum to, let's also do negative, do -2. -1, -2. Y maximum, let's make it 25. Just make it a bit higher so I can see a little bit above where the top of that curve is. Okay, let's graph this and see what it looks like. And I'm thinking that looks pretty good. I can clearly see both sides of the y-axis. I can clearly see both sides of the x-axis, and I can see the top of the curve. Okay, so let's write down our window settings now. So we have -1, 10, 1, and -25, -2, 25, and 1. So we go back here. I'll just write down those window settings. So x was, okay, -1 was my minimum time value. 10 was the maximum one. And then 1 was the scaling. And then y was, I think I went from -2 to 25. And I went up by 1. Yes. Okay, sketch this on the grid. Okay, so let's see where it starts off on the y-axis. Kind of like about halfway up in my screen, and then so actually I'll just draw two dots for the x and y intercept here. So it looks like we're starting at about like right here, and I think like we're coming down right there, and I think the top of the graph is somewhere about like right here. Okay, let's see if we can get a curve to go through these 3 points. Okay, this will be easier for you to do. So let's see if I can actually like not completely botch this. Okay, so come on, go up to the top here. Good. Okay, and then come all the way down. Okay, that was actually surprisingly good for what I was trying to do. I'll make this extend a little bit below the x-axis and just draw an arrow. And same right here, I'll make this one go a little bit to the left of the y-axis and just draw an arrow. Okay, so that's a good graph. And again, once again, you just have to tweak this. Okay, like there's no like absolute procedure you can follow just to like get the best window settings. You have to tweak it in terms of the context of the problem until you can see everything. So I'd say for a curve, like you want to make sure you can see both the x and y intercepts, and you also want to see the spot where you have either the top of the curve or the bottom of the curve. Okay, D says, what is the height of the cannon above the ground? Okay, we're actually going to use a different function to determine the height. So the height says what's the that's the maximum height. Okay, it says what's the height of the cannon above the ground. Okay, the height of the cannon above the ground is going to be right here. Okay, that's where the person's being launched from. They're being launched from this height. They go up and they come back down. Okay, so what are we trying to figure out here? We want the y-intercept. Okay, I'm not going to show you the keystrokes this time. Okay, well, I'm not going to write them down. I'll show it to you. So to get the y-intercept of this graph, we would then go here and hit second, calculate, or second trace, pick value. And then if I want the y-intercept is when x is 0. So at x equals 0, and it tells me when x is 0, y is 12. So if I go back to this, I can say when x is equal to 0, y is equal to 12. And we write this in terms of the actual variables we have. That would be when time is 0. Your height would be 12. And we can add some units here. And it says the height is in meters. So we'd have 12 meters. Okay, now it says what's the maximum height they reach? There's actually another feature on the calculator we can use to do this. So the maximum height is going to be at the very top of the curve. Okay, this is the maximum. And there's a nice feature in the calculator that'll let us figure out the maximum of a graph. So what I want to do to get that, again, I didn't show this one last time. My bad. I think I actually said I wasn't going to show you anything new today. I stand corrected. Okay, so hit second, and then you're going to hit the trace button, which accesses calculate. And then when you do that, there should actually be a function that's called maximum. And I think maximum is number 4. Go to the calculator. So we hit second and then calc. Okay. If there was a bottom of a curve, you pick minimum, but it's the top of the curve, so I want a maximum. So hit number 4. Now it's going to do a similar thing. It's going to say left bound and right bound. Now what this means is I want to put the cursor to the left of the very top, the maximum of the graph. So the maximum of the graph would be somewhere like right about here. So I want to put this cursor to the left of that. So put it to the left of it and then hit enter. And then put the cursor over to the right bound, so the right side of that, hit enter. And that's going to guess that maximum for you. So it's actually really, it's pretty easy to do it. So it says when x is 3, y is 21. Well, 3.00005, we'll just round it to 3. So if I go back here, I could write down, okay, when x is equal to 3, I had y is equal to 21, but it's not x, it's t, and it's not y, it's the height. So the maximum height would be 21 meters. F, how many seconds does it take Kano to reach the highest point he's traveling? Well, we actually just figured that out, okay? Because when we got to the maximum, the time was 3 seconds. So I'll say at max height, which was h is equal to 21 meters. it took 3 seconds to get there. So t is equal to 3 seconds. Okay, G says to the nearest hundredth of a second, how long does it take for Kano to land on the mat? Okay, so when he lands on the mat, that's going to be at a different color. That's going to be at this position. So to figure out the time to hit the mat, we need to figure out the X-intercept. Okay, to get an X-intercept, go back to the calculator, hit second, and then trace for calculate. And then we go down to number 5, or just, no, sorry, number 5. We want X-intercept is a 0, so pick number 2. Okay, then we got to put this to the left side of the X-intercept. So we go all the way down here. Hit enter, then go to the right side, hit enter again, and then it says, do you want me to guess the solution? Hit enter. And it says 7.582577 when y equals 0. It only wants us the nearest hundredth, though, so we'll write down 7.58. Okay, so x is 7.58 when y is equal to 0. Or again, we can write this in terms of the correct variable, so it's not x, it's time. So it would be 7.58 seconds when y, which is your height, is equal to 0. H, how high is Kano 1 second after he's launched? Okay, the easiest way to do this is just to use the trace button and then just identify like which X value you're interested in. So all I'll do is I'm just going to hit trace. And then it says after 1 second. So after 1 second, that would be when X is equal to 1. So I go back here, just hit the trace button. And if you use enter 1, it'll just type in 1. You don't need to write down the X here. It'll automatically like allow you to put in enter an input value, which is X equals 1. Hit enter, and it tells you when X is 1, Y is 17. So when T is 1 second, your height would be 17 meters. Alternately, you can also use the value function. You could go second, and you could hit calculate or trace, and then pick value, and then it actually just prompts you to enter the value in. So if we want the height at a time of 1 second, just enter 1 here, and then it gives you the same thing. It's up to you how you want to do that. Okay, I, it says, when will Kano be at the same height as identified in part H? Okay, so here's the idea that I want to use here. Okay, so at 1 second, he's at a height of 17 meters. So what I'm going to do is I'm going to make a horizontal line go across the graph at a height of 17 meters. Okay, so the height in H is height at 17 meters. So I'm going to do a horizontal line that just goes through the graph at 17. So in the place of y2, I'm then going to enter in 17. Okay, so let's go ahead and do this. So y2, 17. We're going to graph this. Now, if you look at the graph, there's actually 2 spots where you have a height of 17 meters. There's this one right here, which we already identified. That's when the time is 1 second. That's when he's going up into the air. But then when he comes back down into the air, he would also have a height of 17 meters over on this side. So I want to figure out how long does it take to get to this height of 17 meters when he's coming back down. So we're going to use the intersect feature to determine that. We're going to find the intersection at this point here. Okay, so let's say use intersect feature. And again, I'll show you to do it. I'm not going to write the keystrokes out for you because I did it in the previous example. Okay, so I would go second, calculate, and then we'll pick 5 for intersect. Okay, now I want to get this cursor close to that intersection point. So I'm going to bring it to this intersection point, hit enter for the first curve. Second curve, same thing, just bring it close to that intersection point and hit enter again. And then do you want to guess the solution? And enter a third time. And then it says when x is 5 and y is 17. So that's going to be 5 seconds. Okay, so we go back here. So we have x is 5 when y is 17, which means t is 5 when your height is 17 meters. We can add the units in here. So that's going to be at a time of 5 seconds. We're back to that exact same height. J, in words, describe the relationship between height and time. So what that's basically saying is that as time goes up, what's happening to the height? So what I can say is, as time increases, the height at first increases. Okay, so the idea right here is as time goes up, the height first increases and then it drops down to 0. First increases and then decreases after reaching the maximum height. Write the domain and the range. Okay, so the domain is going to be which time values are allowed. So time must start at 0 and it must end when the guy hits the mat. Okay, so when he hits the mat, that was the X-intercept, and that was 7.58 seconds. So the way I'd write the domain is I would say time must be greater than or equal to 0, but it must be less than or equal to the time it takes for him to hit the mat. So it'll be less than 7.58. And then in this area here, time can be any real number. The range. Okay, the smallest that the height can be is when you hit the mat. So that would be a height of 0. And the largest the height can be is at this maximum point at the very top. And that maximum point was when the height was, what was it again? Your maximum height, 21 meters. So what I would say is that your height must be greater than or equal to 0, but it must be less than or equal to the maximum, which is 21. And then in that range, your height can be any real number. All right. So that's it for this lesson. Again, it's really completely built around just getting you more practice with the graphing calculator. And again, the only thing new that I introduced today was just that maximum feature. But again, it's not that hard to use if you already understand how to figure out an X-intercept. Okay, so you can just do 4 questions here. So page 451, do numbers 1, 2, 4, and 6. And I will talk to you in the next lesson.